Firo is secured with a hybrid consensus mechanism, and it's a combination of proof of work, the Nakamoto consensus, which is used in Bitcoin, previously Ethereum and many other projects, and a masternode type of consensus mechanism. And there's a reason why it actually, I think, combines the best of both worlds. And I guess one of the beauties of proof of work is that, as a distribution mechanism, right? When you want to get into a cryptocurrency, you want to get coins, all you need to do is basically have a computer or with a decent graphics card, at least for Firo's algorithm, and electricity and internet, and you can mine and get some Firo totally permissionless. You don't have to buy it off anyone. You don't have to go to an exchange. You don't have to identify itself. So we think this is a really important component of being, a privacy-focused cryptocurrency. So I think that's a really, really important thing of proof of work, and it's permissionless. The other mechanism that we use is called a masternode system, and it was originally derived from Dash. And the idea is that on top of that, you have special nodes that are backed by 1,000 Firo in collateral. And the idea behind is that why does there need to be this 1,000 Firo backing it is because, if they will be critical to, generating consensus on your protocol, you don't want people to be spinning up a million nodes at no cost, right? So the idea of the 1,000 Firo is what we call Sybil resistance, which is to mean there is a cost to spin it up, right? And it also makes sure that there is alignment, right? Because if you're going to use it to attack the coin, you would have to get a substantial amount of the coin, which I guess has similar kind of principles to proof of stake. But it's a different mechanism. So let me explain how this hybrid consensus mechanism works. So the first layer of the consensus are the masternodes. And what that does is that right now on our network, there are about 4,000 masternodes. And, they're controlled by, various people. We don't really know who the identities are. And automatically, groups of 400 of these masternodes that will kind of be like randomly but deterministically selected, and they'll be forming groups of 400 masternodes per group. So at any one time, there are about 3 or 4 of these groups existing, and based on the block that is being solved, it'll be kind of randomly picked. So out of these 4 groups of 400 that keep on reforming every like 12 hours or so, every block there will be like a random chance that each of one of these will be selected. And from that group of selected 400 nodes, what happens then is that they take a vote. These 400 nodes say, oh, I saw this block first. And if they saw this block first, they will sign that block to say, I have seen this block first. And if 60% of that 400 says that, yes, I have seen this block first, that block will be considered final, right? And that's really important because, it means that unlike in pure proof of work where blocks are never really final, right? Because they are all, X for 5 or 6 confirmations or so, you technically can rewind 6 or 7 blocks. You just need enough hash power. But with this masternode system, blocks are final the moment they are confirmed. So one block confirmation, which is why like Binance, which is our largest exchange, allows Firo deposits of one single confirmation, which is really, really powerful. It's great for usability and for transactions. You don't have to wait X amount of time. You know that this money cannot be reversed. Now, so how this works is that, with these groups of rotating 400 groups of nodes being selected all this time, it becomes that if you want to attack our network, you not only have to, first of all, compromise the masternode network. There will be 2 ways, I guess, the main ways that you can do it. Perhaps, maybe control enough masternodes so that you can always vote the way that you want, which is really tough because if you do the math, you need like control of maybe like 60% of the masternode, 60 to 70% of the masternode network to actually be able to mount an attack, or alternatively to kind of DDoS, do a denial of service attacks on these masternode quorums to prevent them from signing the block. So like you see this group of 400, you attack them, right? But because there are several masternode quorums, right? There's like 4 existing and one time they keep on reforming. If you want to attack, you kind of have to attack all of them because you're not sure which is going to be selected. So that means instead of just attacking 400 nodes, you possibly have to attack 1,600 nodes, and that's quite a lot of, it's a lot of significant attack power to bring it down. Once you even bring down the masternode network, the second layer comes in, which is the Nakamoto consensus, which is pure proof of work. And what that means is that on top of compromising or mounting that denial of service attack on the masternodes, you would then have to get and sustain enough hash power to basically overtake the mining network. And even then, you can only rewind the blockchain only to the point where it was last signed. So, let's say the masternodes had signed block 1000, and you manage to bring down the masternode network and you continuously mount that attack. You will not be able to rewind below block 1000. You'll be only able to rewind after. And the whole network can see that the masternode network is down, which is going to make it a lot harder to mount attacks because exchanges will be like, maybe we should not be accepting one block confirmations. Now, some people say, oh, this isn't good. The only way to secure a network fairly is pure proof of work. And I can understand where that comes from because, you say that it's permissionless, there's no need for special node infrastructure. You don't have to host all these things. But that comes with very, very serious, I would say, security risks and also usability risks. Now, Firo, was previously pure proof of work, and we were 51% attack. And if you think about it, for that attack, 50 to 60,000 graphics card worth of hash power was rented to be attacked against us, and that's like a significant amount. And you think about it, it's like there was nothing wrong with our algorithm. There was nothing wrong with our code. This is the way proof of work works. And the attacker then managed to do a double spend. And this is not just a problem that Firo faced. Many other privacy pure proof of work currencies face the same thing. Horizon, Beam, Grin, all were 51% attack. So if you're at a certain size, proof of work alone is a very, I would say, dangerous way to say to secure a network. And some might argue, well, Bitcoin is safe, Monero is safe. Why hasn't it worked for you? There are very different incentive mechanisms there because in the case of Bitcoin, it's being secured by ASICs, and ASICs can only mine one type of algorithm. So if you attack the coin that is giving you money, all your ASICs now do not have any value because you just destroyed the point of your ASIC, right? But that also introduces other problems because then, if you are embracing ASICs, you're giving a lot of power to the ASIC manufacturers. They are controlling the supply and who gets and what, right? And I think this is a huge problem. Maybe not so much for Bitcoin now that it's at the tail end of emission, but it is a real problem, especially if you are still early in your distribution cycle. Now, with Monero, I think it's a different case altogether. And Monero is CPU focused, but it's mined a huge proportion of it is being mined by botnets, which is already an unfair advantage. So what a botnet is someone that has infected like thousands of computers, and they are kind of like they're drones, right? So his costs, like when he mines, there's no cost for him to mine. There's only opportunity cost of what he could be using the botnet for, right? So he is at an unfair advantage versus someone who's just mining fairly with their own computer. With Firo, our algorithm is completely GPU focused. So that means there's no other type of hardware that's mining on it. And right now, at this point in time, there are very, very few, I would say, GPU botnets. It's a lot harder because they tend to be actively used computers that are using graphics cards. So we feel that with this kind of hybrid consensus mechanism, we are getting all the benefits of proof of work with its distribution, its permissionless, and all of that, while still maintaining the usability of the proof of stake type of mechanisms, even though masternodes aren't technically that, but it's offering security and also finality. And then I think that's really important in a cryptocurrency. Obviously, this is not set in stone. We are looking at next gen, I would say, consensus mechanisms, stuff like Avalanche, stuff like, what Radix is doing. But it all comes with different trade offs. And at this point in time, I would say our consensus mechanism really serves the purpose that Firo needs right now. So, hope that explains things.